So first step, as always with induction, n equals 1, and let's see if this expression holds. So if n is 1, so this is 1 minus 1 equals 0. Okay, so 0 is a multiple of 5 because 0 is a multiple of every number. Okay, so this is okay, this is fine, this works. Now next step is to assume that this is true for some n, and we're going to prove it for the next number, n plus 1. So we need to prove that this expression is actually a multiple of 5. In order to do this, we need to expand this product. Okay. In order to expand this, we need to use Newton's binomial formula, which goes like this. If we have any number, two numbers summed and to some exponent, this is exactly this sum. Okay. So we have the sum from k equals 0 to m. So k will have all values from 0 to m of this. This is the binomial number n over k, which has this value. So this is n factorial over k factorial n minus k factorial. Okay. And then product of a to the k and b to the n minus k. Okay. So in this case we have a is equal to n, b is equal to 1, and n is equal to 5. So this is just the sum from k equals 0 to 5 of 5k, and then we have n to the k. Okay, and b is 1, so that doesn't matter. And then we have minus n plus 1. And we can expand this. If you don't know the binomial coefficients by heart, you can work it out themselves. But then, so this the first one will be 1. So then we have n to the, well, I'm doing it the other way around. So this is from 5 to 0. Okay, so n to the 5th power plus 5 times n to the 4th power plus 10 times n to the cube plus 10 again, n squared plus 5n plus, and then 1. Okay, minus n minus 1. So 1 and 1 can cancel each other out, and we could try and get 5n minus n for n, but I'm going to do a different thing. We know that n to the 5th power minus n is a multiple of 5. So again, as we did before, you need to always try to work your way when you're proving by induction to your original expression some way, so that you can use the induction hypothesis. Okay, so that's the whole point of induction, is that you can use the induction hypothesis at some point. And so we have n to the 5th power minus n, and then we have all these other terms. But as you can see, all of these terms are multiplied by 5 or 10, which by themselves are a multiple of 5. So this is a multiple of 5, this is a multiple of 5, and so on. Okay, so we have a number that is the sum of a multiple of multiples of 5. So we could actually factor out 5 in all of these factors. So we know that the sum of this will be a multiple of 5, as we wanted to prove. And that's the end.